Hi, and welcome to a new lesson from Easy Chemistry. This is Mr. Kusai, and today we're going to continue studying about the bondings, chemical bondings. Today we're going to study a new type of chemical bonding, which is the covalent bonding, and it's going to be an introduction to the covalent bonds. Our objectives for today are to apply the octet rule to atoms that form covalent bonds. Also, to explain why atoms form single, double, and triple bonds, as well as to differentiate between the sigma and the pi bonds. By the end of this lesson, you will be able to explain this image. So I recommend you guys to go back to this image, to the beginning of the lesson or of the video, and take a look at this image. Uh, Before we start, we need to recall why do atoms form bonds or they bond with other atoms. Think about the noble gases in this diagram and the reason why they don't form compounds. They do not have a bond between other atoms. Look at the helium. It has two electrons, which is full outer shell electrons. But look also at the neon, argon, krypton, and xenon. All the outer shell of those atoms, they have 8 electrons. So they have 8 valence electrons. So basically, they don't need to lose or gain or share electrons. They are stable, already stable. What do you mean by stable or stability? The stability of an atom is related to its energy. The lower the energy is, the higher the stability. When an atom loses its energy, that means it's more stable now. And all atoms, they are trying to be more stable by losing, gaining, and sharing electrons. That was the octet rule. I recommend you guys, if you have a doubt about the octet rule, to go back and watch the video in the electron configuration and in the ionic compounds. Now, what is the covalent bond? If you check here, before we study the covalent bond, if you check here, we have here the sodium and the Cl. We studied this example in the ionic compounds. And as you can see here, the sodium Na, from the periodic table, it has 11 electrons. So the configuration of the sodium is going to be 2, 8, and 1. That means we have 1 electron or 1 valence electron, 1 electron in the outer shell. And to make those 8, we're going to lose this electron to become more stable. And it will become Na positive, as you can see here. The Cl, it has 17 electrons, and the configuration is 2, 8, and 7. That means we have 7 electrons. This one will lose electron, and the chlorine will gain this electron to become Cl negative. And now we have two ions, positive ion and negative ion, and they will bond together in an ionic bond because it's an attraction between the oppositely charged particles or ions, as you can see here. So in this case, the electron of the sodium was completely lost to the chlorine atom. But in the covalent bond, this is actually not happening. The covalent bond is a chemical bond that results from sharing the valence electrons, not losing or gaining. As you can see here, we have two chlorine atoms. Each one, if you remember also the electron dot structure, each one has 7 valence electrons, so 7 dots in their outer shell. Also the other chlorine atom, it has 7 electrons. Each of the chlorine atom needs one more electron to become stable. So what happens is they will share these electrons. So sharing electrons. Not losing or gaining. Now, this electron from the first chlorine, it belongs to both atoms. Also, this electron from the second chlorine, it belongs to both atoms. If we count now the valence electrons for each chlorine atom, 1, 2, 3, 4, 5, 6, 7, and 8. Also for this chlorine atom, 2, 4, 6, 7, and 8. Both of them, they implemented the octet rule, and both of them, they have 8 outer shell electrons or 8 valence electrons. So the covalent bond, it occurs, or it's a chemical bond that results from sharing the valence electrons between two or more atoms. And don't forget, in the ionic bond, it always occurs between a metal, which is the sodium in this case, and a non-metal, which is the chlorine. Whereas in the covalent bond, it always occurs between a non-metal with another non-metal. Both of the chlorine atoms, they are non-metal. So the bond between the Cl and another Cl is a covalent bond, not an ionic bond. So it's a sharing bond, sharing electrons, and it's between a metal and non-metal. Now, when two or more atoms, they bond together covalently in a covalent bond, we call this a molecule. So now this chlorine, it's called a molecule, and we call it diatomic molecule because di, it means two. And we call it diatomic molecule because it consists of identical atom, the exact same element, two chlorine atoms. So basically, it's a molecule because it occurs by sharing, which means they bonded together covalently. If we talk again about the energy and the stability, the lower the energy is, the higher the stability is. And all atoms, they are trying to be more stable by sharing or losing or gaining electrons to form bonds or to have same electron configuration of the noble gases. Let's take a look now again about the chlorine atoms, like the chlorine molecule, but in terms of the energy. When they are far from each other, this Cl and another Cl, when they are far away from each other, the energy, as you can see, it's here, which is high. And now they are getting closer to each other to form the bond or the covalent bond between them. As you can see, the energy is getting lower, and also it gets lower when the bond is actually formed. Now, of course, if you press these two atoms together closer to each other, there is repulsion will occur. So that's why the energy will increase. But this is the Cl2 molecule, which is the most stable form of the chlorine. All right. So again, the covalent bond, it occurs between nonmetal and nonmetal, and it's by sharing the electrons. When it forms, the molecule will form. And a molecule, the definition of a molecule, is formed when two or more atoms, not ions, are bonded together covalently. All right. Now, because we are studying an introduction to the covalent bond, we need to know all the terms that we are going to use in this chapter. One of the terms is Lewis structure. We studied before in the electron configuration, if you remember, the electron dot structure, and it represents the valence electrons in an atom. So for example, if I have the fluorine, which has 9 electrons, the electron configuration is 2 and 7. So the electron dot structure for the fluorine is going to be F with 7 valence electrons. Because the electron dot structure, it represents the valence electrons in the atom. This is an atom. But the Lewis structure, it represents the arrangement of the electrons in a molecule. So what if I have F2? This is a molecule, and this is a diatomic molecule because the first F has 1, 2, 3, 4, 5, 6, 7 valence electrons, and we need to make them 8. The other fluorine atom has 1, 2, 3, 4, 5, 6, and 7 valence electrons. Also, we need to make them 8. So there will be a bond between them. This is the Lewis structure because it represents the arrangement of the electrons in a molecule. As you can see, this is the molecule. How can we write the Lewis structure for F2? We can write it in both ways. We can write it F, 2 electrons, another F, so that is a bond between fluorine and fluorine, or we can write it simply fluorine, another fluorine, and a vertical line between them. This is the bond between the fluorine and fluorine, and this is the Lewis structure for the F2, for the molecule. So the difference between Lewis structure and the electron dot structure is that the electron dot structure is the valence electrons, or represents the valence electrons in an atom, whereas the Lewis structure, it represents the arrangement of the electrons but in a molecule, as you can see. It's very important to understand Lewis structure because you're going to use it a lot when we study the formation of the covalent bonds. Now, types of the covalent bond. We have many types of covalent bond. We have the single, double, and the triple bonds, and we have some names like the sigma and the pi bonds. We need to understand what is the difference between sigma and pi bonds. All right, let's take this example. The fluorine atom. As you can see here, without writing it again, as you can see here, the fluorine atom, each fluorine atom has 7 valence electrons. They need 1 electron each, so they will share these 2 electrons. Each atom will share 1 valence electron, and both of them, they will have 8 valence electrons. This bond here, we call it the sigma bond or the single bond, because it's only one bond between the 2 atoms. So here I have this example, F and F. This is a single bond, and always the single bond, we give it the letter sigma, and we call it a sigma bond. So the sigma bond is the first bond between the 2 atoms, and it's a single bond between the 2 atoms, as you can see. Later on, we will discuss more about the sigma and the pi bonds. Let's have another example about the covalent bond, which is the double bond. Here I have 2 oxygen atoms, as you can see. The oxygen from the periodic table, it has 8 electrons, so the configuration is 2 and 6. That means the electron dot structure for the first oxygen, it has 1, 2, 3, 4, 5, 6 electrons. The second oxygen atom, also it has 6 valence electrons, so 1, 2, 3, 4, 5, and 6. Each atom, it needs 2 electrons to become stable or to implement the octet rule. That's why these 2 electrons will be shared between the 2 oxygen atoms. So basically we have 2 bonds between the 2 oxygen atoms. We don't call them 2 bonds or 2 single bonds. We call it a double bond, as you can see, because it's 2 bonds between the atoms, the 2 atoms. So this is the double bond. Always the first bond, this one, is going to be the sigma bond. And this letter is the Romanian letter, which means sigma bond or sigma. So the first one is going to be the sigma bond, and the second bond of the double bond is the pi bond, and we give it the letter pi. Now, in the fluorine, we have only single bond, and this single bond is the first bond between the fluorine and fluorine, first and the only. So that's why we have the sigma bond here. So in the single bond, we have only one sigma bond. Now, in this case, we have a double bond. In the double bond, we have the first bond of the double bond. We call it one sigma bond. And also we have a pi bond, which is the second bond of the double bond. So it's going to be one pi bond. So always in the double bond, we have 2 types of the bonds, the sigma bond and the pi bond. The last example for today's lesson is going to be the nitrogen. And as you can see, between the nitrogen and the other nitrogen atom, we have 3 bonds between the 2 atoms. And we call it the triple bond. Now, why is it triple bond between the nitrogen atoms? Let's check the electron configuration for nitrogen, which has 7 electrons. So it's going to be 2 and 5, meaning we have 5 valence electrons and we need to make them 8, so we need 3 more electrons. If I have this nitrogen, and I'm going to write the electron dot structure for this nitrogen, so we will have 5 valence electrons. If I have the second nitrogen atom, which also have 5 valence electrons, so it's both of them, they will share 3 electrons, and we will have the triple bond in this case. In the triple bond, always the first bond is going to be the sigma bond. And the second bond is going to be the pi bond. And also the third bond in the triple bond is going to be also pi bond. That means in the triple bond, we have 1 sigma bond and we have 2 pi bonds. Let's have a quick revision about this. For the single bond, we only have 1 sigma bond and the sharing is only 1 electron from each atom. Here, in the double bond, we have only 1 sigma bond and 1 pi bond, and the sharing is 2 electrons from each atom. And in the triple bond, we will have 1 sigma bond and 2 pi bonds, and the sharing will be 3 valence electrons from each atom. I hope you guys learned something new today. If you have any questions, just write it in the comments. I will read all the comments and will answer all your questions. Have a nice day. Bye-bye.